What does the layers in the protocol stack mean for a packet that is traveling within a network? Each packet contains data that is to be sent from the sender to the receiver. The network needs to provide the service of delivering through layers of protocols in its service model. A packet has in general two parts: a header that contains the control information and a payload that typically contains the packet from the layer above. Each layer adds its own control data in form of headers to the payload received from the layer above. This is called encapsulation. A real-life example for this process is putting a letter into an envelope, closing an envelope, and putting address and a stamp on the envelope before sending it. Each layer is responsible for providing services to its higher layers, and it receives services from layers below. This means for a packet, each layer needs to add its headers when sending and needs to process the corresponding headers when receiving the packets. The real-life example for the header processing is checking if the destination on the envelope is correct, then opening it before seeing the letter. Let's see this process among the different layers of the Internet Protocol stack. When data is to be sent from the network application in the sender, data is received from the network application and the application header is added to it. The packet of data in this stage is called message. Then the application layer message is passed to the transport layer, and transport layer adds its own headers to it. The packet of information at this layer is called segment. Then the transport layer segment is passed to the network layer, where network layer header is added to it. At this stage, the packet of information is called a datagram. The network layer datagram is then passed to the link layer, and link layer header is added to it. The packet of information at this stage is called a frame. Then the link layer frame is passed to the physical layer, and it starts its journey on the link towards the next node on its way to its destination. If the node on the way is a link layer switch, only the link layer header of the frame will be analyzed for it to receive the link layer services of forwarding before it continues to its destination. Link layer header is decapsulated and encapsulated with a new header at every hop. This is because link layer service only covers connection between two neighboring nodes. If the next node on its way is a router, the link layer and network layer headers will be examined. We will further discuss this in the network layer session. When the frame arrives in the destination, for the data to be delivered to the using application, the headers of the link layer, network layer, transport layer, and application layer are analyzed and removed respectively for the data to be delivered to the application.